In this video, we'll be solving +1 problem of the Leetcode, and the problem states that we are given with a large integer, and that integer is represented as an integer array digits where each digit I represents ith digit in that integer, and the digits are ordered from most significant to least significant if we go from left to right, and there are no leading zeros in that, and we has to increment that large integer by 1 and return the resultant array of digits. So if we have a number given 1 2 3, which is given as this integer array, and we'll add 1 to it, it will become 1 to 4, and that will be our answer. Similarly, if we are given with number 4 3 2 1 as an integer array, and if we add 1, it will give us 4 3 2 2. So that's our output in this case. In case we only have 9, if we add 1 to it, it becomes 10, and then we has to return 1 0. So be careful that in the input we only had one digit, and resultant will have two digits because it will become 9 plus 1 becomes 10, and it will occupy two places. So this is the problem. I'll explain how we can solve this problem in a simplified way. If we take the first example, which is 1, 2 and 3, and we has to add 1 to it. So we'll add 1, and our output is 4, 2, 1, and we has to return this. So what we did, we took the least significant position and we added 1, and if it was not 9, we were done. So we don't have to scan the whole array because this remains same. So to avoid scanning whole array, we'll do this operation in place. We'll take the input which is given, and we'll update the same. So the logic would be somewhat we'll scan from the right, and we'll keep on scanning until we are getting 9, and if we are getting 9, so it will be case like let's suppose 1 and 9 and 9. In this case, we'll add 1, but it will generate a carry, so it will be 0. So if the current position is 9, update that position with 0 and move to the next position from the right. And this is again 9, we'll again replace this 9 by 0, and then we'll move forward. Now it is not equal to 9, so we'll just increment this position, and it will be 2, and we'll return this number. So we'll scan from the right and keep on scanning until the number is 9. If it is 9, we'll update this by 0. Otherwise, if it is not 9, we'll update the current position by 1 and then return. Like in this case, 1 2 3 9. So here we'll do it is 9, so we has to replace this by 0, then move forward, and it is not equal to 9, we'll do a +1 to it, which is 4, and rest remains same. So every time we don't have to scan the whole array because we are doing this operation in place. So we'll scan till the position we are getting a number less than 9. So that's the logic. We'll scan from the right. If it is 9, then this position will be updated by 0, and if it is not equal to 9, then the digit position will be incremented by 1, and then return from the function, will return digit. So that's it. So we'll code this logic. As we saw, we has to scan the numbers from right to left. So what we'll do, for I in range len digits minus 1 till -1, and we'll do if digits of I is less than 9. So if it is some other number from 1 to 8 or 0 to 8, then what we'll do, we has to update this position by 1, and then we are done. We don't have to process the digits further, because if it is less than 9 it won't generate any carry, and we don't have to scan further towards the left. We can stop there itself. And if it is equal to 9, then what we'll do, we'll replace that position with 0, because if we have 9 and we add 1 to it, it becomes 10. So 0 will be at that position and 1 will be carry. So that's why we are replacing it with 0. And that should be it. At the very end, we'll reach the end in the case where all the numbers were 9. So we'll have to add 1 also, which is the carry digit. Like in this case, we'll scan the whole array, or in case where there were all 9s, so we'll scan from right all the way to the left, and still we won't return in this condition, because all the digits were 9. It will never go into this if, and it will always update each and every position with 0, and we has to add this 1, and then digits. So that should be it. And this is a Python syntax. This is actually looping from n-1 to 0. And yeah, so I'll take all the examples and then run it. Yeah, examples got accepted. Let me submit it. This also got accepted. So great. Let me just quickly talk about the complexity also. So this is the first line, which is looping over all the digits. In worst case, if we have all lines, it will loop over all the digits in the array, and this will take order of n time. This loop itself will take order of n, and then we are not doing anything additional in terms of time. Everything is constant time, and in terms of space also, we are not allocating any memory which is proportional to the input. We are updating the input itself, and then returning the same input. So our space complexity is constant time. This is the time, and space is order of 1. So this is constant. So that's it for this video. See you in the next one. Thank you.